A lot of content to this.
So we're gonna bust through it. Watch your video later.
All right, let's go through Logistic.
Okay.
Since that's going to be the meat and potatoes. What? I just realized I didn't print out his Logistic
Does anyone have an
concept list.
I have it on my computer. We can open it.
That's okay. I can pull it up on my phone.
All right, you guys have the list right in front of you, the concept list for Logistic. So tell us if we missed something. Okay. Oh, it's in our email? I'll find it while you talk.
All right. So, walled statistic and its limitations. So in SPSS, it's found in the variables in equation table. One of the things you need to know about the walled statistic is it's affected by large B weights. So if inflated or large, the walled statistic might not be correct or accurate. So, huh?
This is on the email list.
Yeah.
At first, are we logistic concept list? Are we going in a row?
Probably not.
Okay.
Probably not. So for large coefficients or large B weights, standard error is inflated, so it increases the likelihood of making a type 2 error.
What is it?
Yeah, so for large coefficients or large B weights, standard error is inflated, thus it increases the type 2 error rate. Walled statistic is like a t-test in multiple regression. So it's a relative measure used to test the statistical significance of each coefficient. I'll say that again. It's a relative measure used to test the statistical significance of each coefficient. And you look at each coefficient, or you look at each B weight, which is a unique contribution of coefficient in the model. Yeah, so the walled statistic is looking at each B weight as its unique contribution in that model.
Do you want me to do the limitations?
Sure.
Is that all you want?
No, I have more stuff on here.
Is there any way that you could repeat what you first said? I was opening up an email.
About SPSS and the variable.
If we're for large efficients or for large B weight, standard error is inflated, thus it increases the type 2 error rate.
Yeah, so it's affected by large B weights. So if it's inflated or large, the walled statistic might not be very accurate.
So you guys should label that as a limitation
Yeah.
in your notes.
Where was it found in SPSS?
It's in the variables in equation table. So another way to think of the walled statistic is it's used to evaluate B weights greater than 0. When it's close to 0, it suggests that there is probably no change as a result of that coefficient. So I'll say that again. So it's used to evaluate B weights greater than 0. Close to 0 suggests there is probably no change as a result of that coefficient.
Ready? Well, it goes into casinos.
Do you wanna?
I think that's pretty much it. That was it for the limitation. So if you have a large B weight, you may do not to everything chi-square, even though
What was the top end?
it is. Did we see that?
One.
Huh?
The top end for that statistic was at 1, like the highest theoretical value for it. Good range between 0 and 1.
I believe so. Do you have that range for it?
I'd like to see the expression, because it means I'm the only one that's like,
I don't have that either, so. Oh, close to 0 probably suggests there's no change.
Yeah.
Do you guys know what makes logistic regression? Like what types of stuff you need for it? What variables? So the DV has to be categorical. Okay, and what about the outcomes? Categorical, and the outcomes are dichotomous. Nope, this is just logistic in general. This is what, like when you would use. So again, the DV is categorical, and then your outcomes are dichotomous. Okay. Yep. And so if you are ever confused about like when you use what statistic, really just refer back while you're studying to your decision tree. And now that you know more about each of these types of stats, it should be easier to follow the decision trees. I think some of you probably are feeling like those quizzes are a little bit easier just because you may know a bit more about hopefully you know more. All right, so next I have the log likelihood ratio test. Yeah. Let's see what he calls it. -2 log likelihood. Yeah. I think that's the same, right?
Yeah.
Okay, so it evaluates to see if the set of IVs improves the prediction of the DV better than chance.
This is negative 2 log.
So again, it evaluates to see if the set of IVs, or in this case, I think he calls them IVs, right? Yeah, if the set of IVs improves the prediction of the DV better than chance. Okay, so it assesses if at least one of the IVs is statistically significant over 0. It assesses if at least one of the IVs is statistically significant over 0. Okay, so this is a type of a fit statistic. Okay, and you might want to use this over the walled statistic if you have smaller samples.
Over the what statistic?
The walled, it could be more reliable for smaller samples.
Wait, you'd rather use this one or the wall?
This one.
For smaller samples, rather than use this one. The lower the score, the better, because it means better fit of the model.
The lower the score, the better.
Because it's a better fit for the model.
A little lost because this is significance.
It's a fit statistic.
It's statistical.
Yeah. So if you notice that, like from each block, your IVs, like if you notice that the statistic, the value is getting smaller, it means that the IVs are better predictors than the DV than compared to chance. So it kind of goes back to the definition again. Okay, so in each block, if you notice that the statistic value is going down, that's a good thing. It means that your model is fitting better than chance would. Does that make sense? Sort of? Okay. And in SPSS, you find it in the table called Model Summary.
Is it true it's also, it's a summary statistic? I have that pronounced.
Yeah, I mean, maybe because it's in the Model Summary table. Okay? All right,
Pseudo R squared.
okay. Pseudo R squared. I don't have that one, so, oh, here it is. Ooh, is this the Nagelkirche?
Uh-huh. So pseudo R squared, it's found in the model summary section in SPS, in their SPSS output.
Is that on your thing?
Is this the one?
Yeah, this is the Nagelkirche.
That's the one.
It's in the parentheses.
Yeah,
Yeah, so this is it.
It's referred to as pseudo.
yeah,
Like pseudo in quotes.
yeah,
Or that's like an also known as everything or everything?
Nagelkirche R squared.
yeah. So the tests are the Cox, Snell, and Nagelkirche. And those all range from 0 to 1. So this is the best way of estimating the percent of variance accounted for in a logistics test. Yeah, it's the best way of estimating the percent of variance accounted for in logistics tests.
And is this just the percent of variance accounted for by the model?
Yep.
as a whole?
Exactly.
Is this, there's one type of square.
This isn't it. This is already squared for you.
Yeah, because don't square it. So if, I mean, example I have is if it's 0.317, what percent would that be?
31.
Yeah, so like 32% of the variance is accounted for by the model.
Yeah, this is the one that's already squared. This one gives you,
Okay. I just remember there being like one that you had like.
There is one,
Very
and it's-
square. It's in the alphabet, you gave us.
All right. Do you have,
it's the conical correlation one.
Okay.
So you want it obviously to go up from, in your model.